Okay, K-mapping is a graphical representation of doing Boolean algebra that you can use about 95% of the time. There still are a few things that you have to do traditional Boolean algebra for, but this will greatly simplify things and make future projects a lot easier. Okay? K-mapping is only good for 2, 3, and 4 variables. Of course, that's pretty much all we're working with is up to 4 variables. You know, with 4 variables, your truth table is 16 rows long. So going to 5 and being 32 would just be crazy. That's why our breadboard companions, but again, this is the basics of all this, we only work with 4 switches, 4 inputs. Oops, I guess we had an example there we could look at. So here's, of course, the Boolean algebra, right? And this is what K-mapping looks like. What you do is you group things in a specific way, we'll go over that ends up to the same simplification. Okay, so that's just an explanation of what we're doing. Okay, so here's what you got to do. Each number, or each column, you always set it up, you start with your knots. So we got A naught, B naught, C naught, C. That's how you would set it up, and all those 1s and 0s are coming from a truth table. And each row and column can only be different by 1 variable. So you'll notice what I have here, I've got A naught, B naught, here is A naught, B, the next one would be AB, and then the bottom one would be AB naught. So that we have every single combination, so you kind of have to pay attention to that. And then what you do is you group things that are groups of 2 and groups of 4, groups of 8, could be groups of 16, but if it was all 16, it's equal to 1, and everything's true, right? You could probably do that without any Boolean algebra. And you'll notice here that we have different ways of grouping things. There's an X there. Oh, they're actually missing a group here. There would be this other term. There's an X there, so I don't even think that's correct. I never noticed that before. But adjacent cells are different by only 1 term. So basically, this is very similar to ORing something. What the step that we're getting, that we are doing with the simplification, when we have something like A, B, or A not B, right? The step that we are doing with this, of course, we can factor out a B, and that's A or A not, which that's B and 1. And that is the step that we're able to simplify with this process. Okay? So what we got to do, you're going to construct a label for the K-map. The 1s will go in corresponding cells, and that wherever it relates to the truth table. You place 0s in all the other cells. And then, of course, each adjacent row or column can only be different by 1 variable. So when we group, there's no 0s allowed, no diagonals. We can group isolated 1s, 2s, 4s, or 16s. The group should be as large as possible. And everyone needs to be in at least 1 group. You don't want to create too many groups, because then you want to have it as simple as possible. So you don't want to create too many groups. When we get into this, we'll kind of see how that works out. And sometimes there are multiple correct answers. I think that even happens in some of the problems on the assignment. Because you do want to use, as the last kind of guideline, use the simplest, the fewest number of groups allowed. You can overlap, you can wrap around. Okay. So, got your example sheet I think this goes wrong. The last page from the assignment has the examples. It says 2.221 K-mapping examples from PowerPoint is labeled at the top. Okay, so this one's pretty easy. Okay, and I'm going to go kind of slow, but how would we set this up? I would start out with J naught, K naught. Okay, and then each row and column can only be different by one variable. So of course this only has two, J naught, K naught, so that will be okay. Now, so J naught, K naught, that's binary 0. J naught, K is binary 1. J, K naught is binary 2. And J, K is binary 3. Right? So that's exactly where I'm going to fill in. This is binary, right? This is binary 0, 1, 2, 3. Everything we do goes back to binary numbers, right? So then what do? And then this one is so simple, you know, there's really not much to do. But we fill in our ones. So we would have a 1 here and here, straight from the truth table. Everything else is a 0. Okay? We have this group of numbers. Okay? And of course, what's different there? What's different there is the k's are different. So this expression simplifies the k's. Since they are different, they will cancel out. And they simplify as J naught. Now we can basically see that from the truth table itself, right? Even without doing the Boolean algebra, we're getting a 1 when J is off. It doesn't matter what K is doing. If we were doing Boolean algebra, my two midterms are J naught, K naught, or J naught K, of course. And then we factor out the J naught, and that's K naught or K, which is J naught, and 1, which of course is J naught. So that would be the steps in Boolean algebra. This one is hardly needs a truth table, does it? Or a K map. You can just look at it and know what the answer is. Okay, got it so far? All right. So we go from 2 variables to 3 variables. It gets a little more complicated. So we got to start off with setting it up. So always start with your knots. E naught, F naught, G naught. And just go straight in order from your K-map, or from your truth table. So then this over here, this would be G, right? And then we would go to E naught F, but the third row will not be EF naught, the third row will be EF. Each row, each adjacent row or column can only be different by one variable. Down here, this would be EF naught. In order to do that Boolean simplification graphically, you can only change one variable between rows and columns. You guys with me? Okay? So you don't have to do this, but I've always found it starts to make more sense. But what do we got? E naught, F naught, G naught, that's binary 0. E naught, F naught, G is binary 1. E naught, F, G naught is binary 2. E naught, F, G, binary 3. But now, there's where you got to pay attention, because it's only different by one row or column. Binary 4 skips down here. This is binary 4, binary 5, binary 6, binary 7. Okay? So this method is super simple. Where you mess up, or if you mess up, it's getting the setup. Okay, so you'll only be different by one row and column. And again, E and F and G, that's 1, 1, 0, binary 6. E, F, and G, binary 7. E, F, not G is binary 4. Or E, F, not G, not E, F, not G, binary 5. Again, that's coming straight from here. Binary 0, 1. You know, the truth table should always be done exactly in order. And even when you breadboard, whether it's in simulation or whatever, always check your truth table to make sure everything, a lot of you on your last project, you just wanted to show me the ones where the light turned on. No, we always check every single row in the truth table to make sure it's also off and it's supposed to be off. Okay? So then we fill in all our ones. So what do we got? We got 1 is a 1, 0, 0, 1, 1, 0, and then we would have 6 is a 1, 7 is a 0, 4 is a 0, 5 is a 1. Okay, with me so far? So now we can group ones that are alike or next to each other. You can't group diagonally, but you can do a wraparound group. You can see the top row and the bottom. The top row and the bottom row are only different by one variable. So you can do wraparounds vertically and horizontally if you get to 4 as well. Okay? Because they're only different by one variable. So let's see, what will that give us? So then here, my first group, I have E not F and EF, or EF. So what variable is different? Huh? E is different. So the E is different. So since the E is different, that's going to be FG naught. Okay, because we still have that term from the column. So that'll be FG naught. And then on our other group, what variable is different? The E is different. So on that one, the E will cancel out. So that would be F naught G. Okay? Make sense? Yeah? Now we got the big boy. All right, so 4 variables, RSTU. What's my first row going to be? What variables would I use for my first row? R naught, S naught. Second row, only change one variable. Keep going how we did the last one. R naught S. Third row would have to be RS. Fourth row, RS naught. Okay? Only changing one variable, and you have to set it up that way every time. I mean, that's the devil's in the details on this. You have to set it up right. Our first column will be what? T naught, U naught. Our second one would be T naught U. Our third one can only change one variable, TU. And our last one, TU naught. So of course, what do we got? Binary 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That doesn't look like a 4. Right? So, if we are looking at these boxes, kind of like a Sudoku puzzle, but not quite, right? So this is 0, binary 1, binary 2, binary 3. It skips. Skips a little bit more. So then we would have binary 3, RS, T naught, U naught, that's binary 4. Binary 5, skip. Binary 6, come back for binary 7. Skip a row, and we'd be at binary 8. Binary 9, skip for binary 10, come back for binary 11. And then binary 12, 13, skip, there's 14, binary 15. Okay? Now, you have to write the numbers. You will not see those binary numbers written out on a K-map, on a quiz, or on a multiple choice test, or whatever, and of course exam. You will not see it written out that way, but in teaching it, I found it helps to make that correlation between these variables and what binary number they're at in our truth table. Okay? So if we get this set up right, it's now easy. So let's go back and fill out our numbers. So what do I got? I got 0, 1, 2 is a 0, 3 is a 1, and then 4 is a 0, 5 is a 1, 6 and 7 are both 1s, 8 is a 0, 9 is a 1, 10 is a 0, 11 is a 0, 12 is a 1, 13 is a 0, 14 and 15 are both 1s. Okay, so we can group we got a lot of groups here. We can group 1s, 2s, or 4s. 1s, 2s, 4s, 8s. Can't group diagonally. So I usually try to start with my bigger groups first. So I do have a group of 4 there. I have an overlapping group of 4 there. And then, looks like the simplest version would be, I'd have a wraparound group that way, and I got a horizontal wraparound that way. So my first group of 4, let's see, what variables are different? The S is different on the top one, and then the T is different. So that term would be what? R naught U. My second group of 4, what do I got? You know, on the rows, the R's are different. On the columns, the U's are different. But what's the same? The same would be ST. Okay, on my vertical wraparound group, what's different? The R is different, so we keep everything else. So that would be S naught, T naught U. And then on my horizontal wraparound group, what's different? The T is different. So that would be RS U naught. There we go. Okay, let's get the don't care example. We'll come back to that tomorrow. And then so if we start looking at the assignment, let's see, the first one, the first couple is already filled out. All you got to do is group them. What if we can do 1 to 9, I think. So what that looks like, we do 1 through 9. Let's see what some look like. Oh, 1 to 6. Oh, you got 2 different groups of 1, 2, 3. You can do the first 6 questions. Because then after that we have, oh, no, you can do the first 9. You can't do the first 9. But yours are not labeled 1 through 9. Yours are labeled 1, 2, 3, 1, 2, 3, 1, 2, 3. They did funky numbering at times, and they fixed it then because they realized that was kind of a dumb idea, but then I didn't print you the one that got fixed. I printed you the old copy. That's all right. And then kind of the first one, all you got to do is do the grouping and write the terms. And then the next one, you got to fill in the second group of questions. You got to fill in the 1s and 0s. But the K-map is set up for you. You just got to fill it out, group, and write the terms. And the third one, the next group of questions, you got to do everything. Okay?
So I just take this and wipe it on, but not too much?
Yeah.
Okay. I'll put on turn number. And then we do this each day for like 2 days, or?
You need depends how much you want 2 to 3 coats on it.
Okay.
It's not getting a lot of wear. Your
Yeah.
guitar, you're going to want 4 to 6 thin coats.
Yeah.
You want to protect the guitar. Yeah, and you want 2 or 3 coats on your jewelry box,
Okay.
or card box, whatever. Okay, what happened to the recording? Oh, it's still recording. Okay, we'll stop.